This method turns standard web scraping on its head, trading off slightly more setup for a few key benefits that, although are quite niche, are very good. Let me explain. Conventional web scraping works by requesting HTML, passing that HTML, and then saving the transformed output into our desired format. But this can pose a couple of problems. So in this video, I'm going to propose a slight change to the conventional method. We'll talk about what that change is, how it's so effective in the right situation, the benefits of it, and then we'll code out an example. So I've scraped millions of rows of data, and with this method we solve a couple of key issues. Errors while parsing, and not being able to go back to the HTML from that given time, and having to write out extra code to scrape more sites. We're going to write generic code that takes a list of URLs, scrapes the HTML, but crucially, we're going to save the full document to our Mongo database. We store the URL, the HTML text, and a timestamp. This means we can parse it later at our convenience, avoiding any parsing errors, and also, should we need to revisit it for any extra data, we can, as we now have a timestamped record of the page, which is also very useful for pricing and product changes and updates. And because we're separating out our code, giving parts specific jobs, we can reuse that request part over and over again for any site we want. And each new site added is just writing parsing code. By doing this, it gives us more structure to our scraping code, allows us to easily use Python's async abilities to download data. So let me show you. To get started, we are going to need a Mongo database. You're also going to need a way of interacting with that database, and I'll use Compass. It's just nice and easy, GUI, etc. Here is my version. To install Mongo, I would recommend Docker. I run mine on my home server via Docker Compose, which looks very similar to this. Once you've got it up and running, it's dead easy to come onto Mongo and Compass and connect to it just by typing in the URL or localhost and the port. Once that's up and running, we can continue with our Python code. Now, we have a few choices here, but we do need to make sure we have a few things installed which are mandatory. PyMongo being the first one, so we can talk to our Mongo database. And I'm going to use curl CFFI, which is a HTTP client within Python that utilizes a load of cool tricks to get around certain fingerprinting. You can absolutely use any HTTP client that you like for Python. I just used it in this project because I quite like it. You will benefit from an async client though, which this is, but also AIO HTTP is, and HTTPX. Of my favorite ones, use this one or HTTPX. So we're going to also use Rich because Rich just makes it nice and easy to print stuff out to my terminal, and that should be enough for us to get started. I'm going to create a new terminal in my tmux, and now we got this installed. I'm going to create a new file. I'm just going to call this main.py, and then I'm going to open it in my code editor, which I'm using Helix. Use whichever one you like, it doesn't matter. So the first thing that we want to do is just import everything that we need. We're going to be doing async in this, so I'm going to be using async IO. I'm going to need OS because I'm going to be pulling my proxy from my environment variables. Now you will need a proxy, especially if you're scraping async. I save my proxy string in an environment variable on my machine. You can just put yours directly into your code too. But if you need a proxy, you're going to want to check out ProxyScrape, which is the sponsor of today's video. I've sent countless amounts of data through ProxyScrape, and these are the proxies I'm using today and the ones I've been using for the last year or so. So as we know, proxies are an integral part of scraping data. And with ProxyScrape, we have access to high quality, secure, fast, and ethically sourced proxies that are perfect for our web scraping use case. I almost exclusively use residential ones, as these are the best option for beating any anti-bot protection, and with auto rotation, we're able to scale up our scraping solutions with ease. There's 10 million plus proxies in the pool to use, or with unlimited concurrent sessions, so adding proxies to our project is simple and extremely effective when combined with any scraping code, but especially asynchronous requests like we're going to be using here. You'll have a choice of country too for when working on very region specific sites. There's a 99% success rate and traffic which never expires, which is also very nice. Other options though, if you just want throughput, then data center proxies with unlimited bandwidth, 99% uptime and no rate limit from reputable countries and IP auth makes them a very attractive option for the right use case. So go ahead and check out ProxyScrape at the link in the description below. So on with our project. Now we're going to do from curl CFFI, we're going to import, we need to do .requests actually. We're going to import in the async session. This is what we're going to use to make all of our requests. I'm going to import logging. I'm going to talk about that in just a second. And I'm going to import in from rich .logging. We're going to import in the rich handler, capital R. There we go. I'm going to import in time just so we can see everything that's going on when we want to see how quick we're going. And from PyMongo, we're going to import in Mongo client. Now, just before we get started, I want to say that I'm going to include some things in here which aren't mandatory. I will tell you what is mandatory and what isn't. So the first thing I'm going to do is I'm going to import in my logging. I'm going to put this in here just so you can get an idea of what I'm doing. This is not mandatory, this section. This is just logging for what I'm doing. If you don't want to have any logging like this, or you want to use print statements to log, that's fine. This section is optional. I'll type that in, optional. Definitely worth learning how to use logging though, if you so desire. So the crux of the main part of this is our async function. So I'm going to write that first, and this is of course mandatory. If you're using async, I highly recommend you use async because we don't need to worry about parsing because we're doing that later. We can use async to its full effect and not have to worry too much. So I'm going to do async run. Let's put this in the middle of the screen and we'll have this function here. So we're going to do async with, and this is our async session as session. Now I'm going to grab my proxy. So our proxy is going to be equal to os.get env. I always do that, get env. And you can either type it in here, or if you want to, we're going to create a constant. We're going to call this proxy. I'm going to go to the top of the code. I'm going to say that my proxy for my environment variable, like so. This is just so I can easily rotate and use different versions. I have many different ones that I use from Proxy Scrape, and the one I want to use for this one is called this in my environment, sticky proxy. This is a one that is a sticky session that rotates every 5 minutes. I think I've got it going as. To make sure this is working, I'm going to say if proxy is not none, and I'm going to do log.info. This is my nice rich logging. I'm going to say proxy found from env from my environment, and then I'll do session dot proxy, so I can update my session with my proxies, which is not this. It's equal to, it's a dictionary, HTTP, and the proxy, and HTTPS also with the proxy. Again, proxies are kind of mandatory when you're doing this. You don't have to, but you'll probably find your IP will get blocked very, very fast if you make a load of requests very, very quickly, which we will be doing because we're going to be using async. And I'm just going to put a warning in here, so I'm just going to say no proxy found. Continuing without. Cool. I don't know if that's how you spell continuing, but that's what we'll do for us. Right, the async part is we're basically going to create a load of tasks. And what these tasks are going to be is each URL, which is going to be then done inside our coroutine, so we can have everything going at the same time. So I'm going to do for URL in URLs. I'm going to create this URLs list in just a minute. I'm going to do task is equal to our session.get that URL. So we want to use this to go and get our URL, and then we'll say our tasks.append our task. So basically creating a load of tasks which we're going to then run here, what I'm going to call result, because we want to get the information back from these HTTP requests with a wait, because this is our async. We want to do async io.gather tasks, and that's going to make everything go at the same time. It's going to get all of the information, it's going to wait for them all to come back, and then we're going to have a nice load of data within results. And this is probably only going to take a few seconds depending on how many URLs you're running. And then from out from this function, we want to return our result. So from this, I recommend you use a proxy. You could of course just do this string here and put your proxy string that you get from Proxy Scrape directly in this variable if you want to. I've just done this because I want to make sure that I'm pulling different ones from my environment that we can then use depending on what I'm trying to do. And I will also get a log when I run this if it hasn't picked it up from my environment, so I can avoid using my own IP for such things. Then we create a load of tasks with our URLs, which we are yet to create. We gather all those tasks together, we wait for them to all be done, and then we return the result. This is mandatory, this section, because otherwise we're not going to end up with any URLs. You could do this synchronously, one after the other, for URL and URLs, and then get the HTML and then return it out. But that's going to be super slow. From this, we want to say our data is going to be equal to asyncio.run on our run function. I probably should have called the run function something else. You get the idea. We're basically saying, now with async.io, let's execute this function. And that's going to get everything for us. Now we're going to have all of our results, data back here. So we do need some URLs. So what I'm going to do is I'm going to say here, we're going to do with open, because we're going to pull these from a CSV file. And I'm just going to say our urls.csv, read as f. It's up to you how you get your URLs. You could scrape for them. You could pull them from a database. In this instance, I'm just pulling them from a CSV. All you need to make sure is that you end up with a list of the URLs you want to get asynchronously. So our reader is going to be equal to csv.reader. And I didn't import CSV. That's interesting. Okay, and then URLs is going to be equal to URL, the first index, because otherwise we'll have a list of lists for URL in our reader, like so. Let's import CSV because we're going to need it, as we can see. Now, if I come to my file, I've dumped in the list of URLs we're going to be working with. There's 80 in here, so that's a reasonable chunk to get working with. So let's come back to my code editor, which I closed by accident. There we go. So now we have our URLs, which is going to go into this function and return the result. So what I'm going to do now is I'm going to run this. I'm just going to print out the data that we get back, and we'll save, and then we'll come over here. We need to activate our virtual environment, clear the screen up, py main, and we should get proxy found from environment. That's our logging. This is rich logging, lovely colors and everything. So we're actually creating all the requests now, and we're just going to wait for them all to come back before we do anything. And there we have it. These all look like 200 requests, which means they were all successful. So we are going to come back to our code now, and I'm just going to paste this string in here, which is one that I've copied from online. I apologize, I can't remember where I copied this from. And we are now be able to tell how long this takes. Let's run it again, see how long it takes. I think it takes about 5 or 6 seconds for 80 URLs, which is not so bad. Compared to if you did them one after the other, it would probably take about 9 seconds in that case. So not bad. So let's go back to our code. And now we can think about what we're going to do with MongoDB. So I'm going to put mandatory here. So I like to store my Mongo data up here. So I'm just going to copy this over so I don't have to type it out, and I've chopped the M off. So what I've got is I've got the connection string. I've got the port, which is actually a different port. I think it's this one. Let me have a look. 69, perfect. And I've created a database here and a collection within this. Now, you don't have to do this, because when you do this here, if that doesn't exist, it will create it for you. But this is my database and my collection, and this is important. And I also have the port here. So with these, I'm just keeping them as constants at the top, just so if anything changes, it's easy just to go to the top of the file and change it here. You could, of course, put this in line if you wanted to. So now we have our data out here. We're going to need to add in our Mongo information so we can do something with this data. So we want to create our Mongo client here now. So I'm going to say our client, actually we'll call this Mongo client, it's probably easier, or M client. That's not very Pythonic. Doesn't matter what you call it. And that's going to be equal to the Mongo client that we have imported in from PyMongo. And we need to give it our MongoCon and our Mongo port. And then we want to say that our DB is equal to the client, and we want to give it our MongoDB. In this case, it's called scraped items. And then our collection is equal to DB and of the Moncol. There we go, perfect. That's the wrong thing. This here should be M client. There we go. So now we have access to our collection. We can easily go ahead and add stuff into our Mongo database. So underneath where we're getting all the information, we want to go through that responses that we saw on this screen here, and we want to get the HTML from them. So we're doing no HTML parsing. We're going to store the raw documents in our Mongo database with a timestamp and a URL so we can parse them at a later date whenever we need to, or revisit them if we need to. So let's do for response in data, and I'm going to say if response dot status code does not equal 200. We're going to do log.warn because we want to warning this out. So I'm going to do failed on response.url with code. This is just some logging response.status code. You'll thank yourself later when you try and run this again at a different time, and you have this lovely logging in here that tells you what's going on. From here, what we could do is we could create a failed list. Let's call it failed, and then we could do failed dot append, and we could just store the response.url. So we have a list of anything that failed. We can revisit them or do whatever we want to do. But if it does have a response code of 200, we'll have results. Let's create that list actually whilst I'm here. So we have a failed list and a results list. That's cool. Results.append. This is where we want to construct the information that we're going to be storing in our Mongo database. Don't like it like it does that. We'll do it like this. Thank you. So we want to say we want the URL, which is going to be equal to the response.url. We want the time or the date. So we're going to have date time dot now, and this is going to create a date time object, which will go neatly into our Mongo database, and the HTML, which is the important part, which is our response.text, like so. Great. Now we want to add this to our Mongo database. So I'm going to come outside of the for loop, and we're going to use insert many, and this is the Mongo part. So we'll just do inserted is equal to collection, which is the collection that we stipulated at the top, dot insert many, and this just takes in a list of JSON objects results like so. That is essentially it. This is the one line that it takes to import stuff into your Mongo database once you've set it up and added it in. Nice and easy. This is essentially it, about 80 odd lines of code where, you know, we're going to take a list of URLs, and it can be any URLs. We could create argument parser, argparse, to change these, or we could just change it manually. And we're going to then asynchronously, with our proxy from PROXIES, go through, get the response from all the URLs. We're going to go through them, and then we're going to save each and every response into our Mongo document database for us to handle later. So we're pulling all the information, we're storing the raw data, and then we're going to parse it later and move it to wherever we need. And when we do that parsing, we could remove that document from the database to keep it neat, so we know only the items in this collection are the ones that we want to still parse, or anything else that suits us in that instance. And it's super easy. So I'm going to clear this up. I'm going to run py main, and we should have a little pause because I've got nothing going on in between with all the requests. We should see all the responses and the insert statements come through in just a second. I think it took about 10 seconds last time. There we go. So it took 16 seconds all in all to request 80 pages from the URL list and store them all in our document database, in our Mongo database. Let's scroll up, and you can see we've inserted results, and we have all the document IDs, the object IDs there. And if I come over to our thing here, our Mongo compass here, and hit refresh, here's our documents, all 80 of them, and this is what they look like. You can do them in different views if you want to, but this is the raw HTML. So all we need to do is we need to say, hey, give me every entry in the products collection. Then we can just give the HTML parser the HTML, and we can figure out what we want to pull from this. And then we could move this document to maybe a completed collection, Maybe we create a new collection called completed and move it over there. Or maybe we just leave it and we say, give me all the documents in this folder from this date, and we pass those out. Or we have one collection per website, etc., however you want to manage it. The good thing about document databases like this is they're very, very easy to use. But the downside is working when you have relationships in your data is not so great. So if you're storing past data that you've put into a specific schema, I wouldn't use Mongo. I would 100% use Postgres for that and set it up to do that. This is just a great interim database for storing raw HTML documents like so. So hopefully you've enjoyed this video. If you want to watch me do some more traditional web scraping using Python's best web scraping framework, watch this video next.